So good evening po Sir Jay and Josh. So
Good
we'll
evening,
have
sir.
we'll have our another problem about our lessons, previous lessons. So this time we'll have naman the strength of ionic bonds. So usually, Josh, the strength of ionic bonds can be measured by what parameter again?
Lattice energy.
Very good, the lattice energy. So, and then we can actually approximate the lattice energy using what method?
The Born-HABER cycle.
Okay, so using the Born-HABER cycle, which is a form of Hess's law. So if you will recall in our thermodynamics, we can actually approximate the value of lattice energy. So I'll be sharing now my whiteboard, and then ayan. So I'll be giving you a problem, specific problem, so that before we go to our next lesson, so this will assess your learning about the Born-HABER cycle. So for this one, let's say I'll give you um, sodium oxide. Okay. So please take note of the formula. So you have two sodium atoms here and one oxygen atom. Okay, so go ahead. So what is our first step?
So at the
So you'll now be creating your Born-HABER cycle diagram. So okay, go ahead. So I'll open my video later if I need to emphasize something. So you can do also annotation.
Annotate, nag-ano ka ba na annotate? Yung annotate.
Okay, sir.
Ay, ayaw
So,
po eh. Hold on po, sir. Sorry.
okay, go ahead.
there we go. It's done.
Can you now do annotation?
Alright.
Yeah, I can see your annotation now. So go ahead. So you can now start your Born-HABER cycle diagram.
So the very bottom is so
Okay, good.
slight
Continue.
so ito po.
Okay, correct.
So this is the delta H sub.
Okay, good. So why it's delta H sublimation again?
The enthalpy of sublimation from solid to gas of sodium dot.
Okay, good.
Okay, so this naman. And then
Yeah, okay, so you started off with sodium oxide as your lowest energy chemical species. That's correct. So that is your what again?
delta H formation.
Okay, so why it's delta H formation? Because we are forming what?
We are forming Na2O po.
How
The
many moles of Na2O?
1 mole.
1 mole, very good.
Yes,
That's the reason why you started with two moles of sodium solid, then 1/2 mole of O2 forming sodium oxide. So that is the definition for formation reactions.
Aba.
Okay, you may now continue your diagram. Okay, so for that one, it's your
First ionic energy. Oh,
okay.
squadron pa rin po.
Okay, so first ionization energy. Can you define ionization energy again as a review?
How much, either
Or
it's either how much energy po is needed to ionize for the ionized gaseous gaseous atom or molecule, or it could
okay,
be ano
good.
naman po, it could be the opposite, but then
Yeah. So I is the amount of energy required to remove an electron from a gaseous atom. You now form your cation. So go ahead. So you may now continue your diagram.
so okay.
Okay, so correct. So in this transition, what happened naman? Okay, that's also an increase of
But the
energy.
OO band po is broken.
Okay,
BDE
good.
and
The
dissociation.
oxygen bond. So BDE is what again?
Band dissociation energy.
So the band dissociation energy is again what is its definition? This
Uh,
is
the amount po to amount of energy po to break the band po.
very good.
Could also
So
be
usually,
the amount of energy po to form the band, but usually ito tayo mas ano naman
correct, good.
definition.
So usually the amount of energy to form the bond and the amount of energy to break the bond, they are equal in nature, but the first one will be the latter will be endothermic or the BDE.
Opo.
Okay, so go ahead. Next step. So it's really a good thing or a really good model that you use different colors for your arrows so that we can easily indicate the endothermic and exothermic reactions here.
So
Okay, there
the
you go. So what is that transition step
first EA or the first electron affinity. So when oxygen
of
will
what?
gain of
Okay,
oxygen
good.
will gain the
So can we recall what is electron affinity again, Josh?
how much
The first
energy
EA?
how much energy is released when an atom receives an electron. The
Good.
opposite
So
of
for
I.
the first EA, yes, the opposite of I. So for the first EA, this is usually exothermic. So oops. So this is usually exothermic because where your atom is accepting an electron. So, good. So
So high.
but oxygen, di ba? You ended up with oxide O negative, right? So what you want is
O2 negatives, the most stable po,
very good.
oxygen.
So you'll have another what?
Another leap in energy.
Very good. Another EA. So please yan. I'll correct lang this one ha. I'll add the EA here. Good. Okay, just continue what you're doing. So after getting the second EA, Josh, what will happen now?
Now
You'll end up with
we'll end up with 2Na Na plus gases plus O2 negative.
okay, good. So what is the reason again why the second EA is endothermic?
O2 minus plus the most stable form of oxygen.
Okay, good. So, mhm. So what we want is from O negative, we want a more stable form of oxide or the ion. So we need to input energy. So it's an endothermic.
Right, so we've reached the lattice energy po.
Okay. So then So a while ago, I've already given you the different values for the different energies. So can you just write the different values here? So yeah, go ahead
Uh,
so that we can actually see the
Column. It's
values.
any column.
Okay, so let's start with the delta H knot formation.
Equals.
So,
Equals.
okay, good. Mm-hmm. Good. And then just continue doing it for the rest of the other variables.
Okay, ulit naman.
Okay, so I'll be erasing lang your Na2O ha. I'll just place it
Opo.
in the upper portion of your um, this one so that we can have the equation there later. So this is your Na2O solid. Good. Okay, continue.
So, there you go po. All the values are in place.
Okay, good, good, good. So if you have all the values now, so Le is equal to what?
L is okay with
Okay, go ahead. Lattice energy will be equal to what? Okay, good. So we'll be having the delta H knot formation. Okay.
Oops. Okay, so the EE pala is the total. Output EE.
Correct. Since you have two EAs, it's a total.
So,
Okay, go ahead. So this is your total EA. So therefore, do you need another page for this?
maybe I need po.
Okay, go ahead. There.
Okay, so substitute the each.
You can now input the values
I'll just write this again.
in the equation.
So I might forget. Okay, equals negative 416.
Okay, good, good, good.
Oh, so there will be some variances here.
So usually the energy values here are expressed in what unit.
Kilojoules per mole.
Very good. So
Yes.
please be guided with the units, Joshua. So if ever you'll be given with a different value or a different unit for energy, you need to convert that first so that you'll have a smooth
Opo.
calculations for energy. Yeah.
Mhm.
Okay, good, good, good. You're doing good. So what is that again? That's the total, what?
EA.
Very good. The total EA for your oxygen atom. Because what we want is your oxide, O2 negative. Okay,
Oops. O lang pala.
so what will be the total?
Equals, wait lang, to calculate.
Okay, good. So we'll now have the final value for your EA. Go ahead, calculate it first using your calculator.
Equals negative
Negative.
476.
Okay, good. 47 kJ per mole. Good. So, yan. What is this value? An exothermic or endothermic value?
It looks like ano po, it looks like it's exothermic.
Good. By virtue of
At
its
least
yeah,
sign po.
because it's sign negative, right?
Aba.
So if that is the case, let's go back lang ha. Based from your diagram, we can see here that the lattice energy is going down, right?
Aba.
The value is going down. So it means this is exothermic. That's your lattice energy.
Aba.
So is lattice energy can be also a positive value?
It can
So
also
I
be
just
po
want,
a positive value, rarely po. But then
correct.
usually po, it's usually just exothermic po for most.
Okay, or yeah. So, but it depends on the orientation of your arrow, or it depends on the how your reaction will proceed. So this time
Aba.
kasi, the lattice energy, we define lattice energy here by forming your sodium gas and then oxide ion gas to sodium oxide solid. So it's bond formation, right? So
Aba.
that will be exothermic. So lattice energy will be, what will be the value of lattice energy again? Just the
Exothermic
sign,
po. Negative po.
negative, very good. Pero if we have the reverse, let's say the energy needed so that we can form the um, gaseous ions from 1 mole of your ionic solid, what will be the value this time of your lattice energy?
Positive po.
Okay, good. So please recall that lattice energy, it depends on the direction of your arrow. So it
Aba.
will be negative or positive, but the same magnitude. So
Aba.
good job, Josh. So ayan.
Thank you po. Thanks for watching.